All right, this video is for section 5.6 of Math 1050. The topic is linear programming. In ALEKS, this is literally just one topic. The problems are very challenging though, and they take a lot of work to get through. When a company manufactures a product, the goal is to obtain maximum profit at a minimum cost. Or sometimes they're trying to minimize something in order to, like maybe minimize cost in order to get the highest profit. Oftentimes production is limited by certain constraints, such as either the labor or the capacity of the machinery or the amount of money available to invest in the process, or sometimes just time is a constraint. So this linear programming is a way of sort of considering all those constraints and figuring out a way to maximize or minimize a function. So we're going to go through 3 examples. The first one is about blending together some coffee packages. We'll do one where we're manufacturing toy airplanes, and then the final one is about a company trying to sort of manage their mining operations and minimizing the cost of running those mines. So I'm going to go through those 3 problems. I wish I could do less examples with you, but I feel like it takes a few examples before you get a good handle on the process. So the first one says, for a given week, Teresa's Coffee House has available 1,728 ounces of grade A coffee and 1,760 ounces of grade B coffee. They blend these into 1 pound packages as follows. They have an economy blend that is 2 ounces of grade A and 10 ounces of grade B, and then they have a superior blend that is 9 ounces of A and 2 ounces of B. The remainder of each blend would be filler ingredients. So the company makes a $3 profit on each economy blend and a $4 profit on each superior blend. So assuming they're able to sell as many blends as they are able to produce, how many packages of each blend should the company make in order to maximize profits for the week? So the first question that you should ask yourself is, what am I trying to maximize or minimize? And in this case, we want to know how many packages in order to maximize profits. So we are trying to maximize profit. So we need to think about how to write an equation for profit. Well, the profit is equal to, they make a $3 profit on economy. So I'm going to call that 3E. For each E bag they sell, they get $3, and a $4 profit on a superior blend. So 4S is added, $4 of profit on each superior bag. Okay, so what our goal is to get as large of a profit as possible. So now we have to think about the constraints that we have in this situation. I'm going to use E and S as our variables. In another example, I will just use X and Y, and you could just use X and Y if you want, but I'm going to use E and S. Sometimes if I use letters that stand for things like economy and superior, sometimes that helps me keep it straight better. Okay, so what we need to do is make some constraint equations. So what you want to think about is, what do you have totals on? And in this problem, the thing that we have totals on is grade A and grade B. So we're going to make a grade A and a grade B equation. So for grade A, what we know is that for each economy blend, they need 2 ounces of A. So 2 ounces of economy blend in A. Now I'm trying to write an A equation. So I need 2 ounces for each economy bag. And it's really hard at first to read these sentences and come up with an equation. I'm focusing on grade A right now. So 2 ounces for an economy blend. And then if I keep reading, the next time A is mentioned is that a superior blend is 9 ounces of A. So 2E plus 9S. So that's the grade A coffee they need to create these bags. And then we know that they have 1,728 ounces of A available. So however much they use in those bags that they're creating, it can't go over 1,728. So that's our grade A equation. Now, we need to also create a grade B equation. For grade B, what we know is that we have 1,760 ounces. So I'm going to go ahead and put that down first this time. In an economy blend, we need 10 ounces of grade B. And in a superior blend, we need 2 ounces. So there is our grade B equation. All right, so when we're doing linear programming and we create these 2 constraint equations, what we want to do is graph them as an inequality. So because, a lot of times when we're graphing, and it is just a line, but a lot of times when we're graphing a line, we're used to having it in this form. And you could certainly solve this, but they're not nice numbers. They're not like between 0 and 10 like most of the graphs we do. So an easier way to graph these equations is actually to figure out where their intercepts are. So we're going to look at if S is 0, what is E? And if E is 0, what is S? We're going to find the 2 places where it crosses the axis, and then we can just connect them to get our line. So, let's start with E is 0. If E is 0, find S. So if E is 0, we get 0 plus 9S is, and for the sake of finding the intercepts, I'm just going to use equals 1728. So I subbed in 0 right here. So I got 0 plus 9S. So if I want to solve that for S, I just need to divide by 9. And 1728 divided by 9 is 192. So I'm just going to go ahead and mark on my axis somewhere in the middle, 192. And that's my my intercept on my S axis for when E equals 0. So now I'm going to do the same thing and set S equals to 0. If S equals 0, I'm setting this S equal to 0, so I end up with the equation 2E plus 0 equals 1728. So to solve for E, I just need to divide 1728 by 2. That's 864. And again, I'm going to just kind of put it kind of in the middle. And those lines would connect. Now this was in the original equation, this is a less than or equal to, so we're going to shade below that line. This is not a very good line, sorry. Okay, so the blue line is grade A, and we would shade below it. Okay, so now let's focus on the grade B. Same process. If E is 0 on this equation, setting E equal to 0, we would have the equation 0 plus 2s is equal to 1760. And so if we divide by 2, we get s equals 880. So up much higher. Now you can kind of see why I put it in the first one in the middle, because I didn't know whether this one was going to end up higher or lower, or maybe logically you could have figured out if it was going to be higher or lower. But I like to just kind of put my first one-ish in the middle, and then I can decide where the other one's going to fall. Also, not to scale. It's a rough sketch to help us think through the situation. It doesn't need to be accurate as far as like counting out, a specific scale. Now we just need to do the same thing. If s equals 0, we need to find our e value. So we're going to sub in our 0 here, and we get 10e plus 0 equals 1760. So then if we divide by 10, we get e equals 176. Definitely less than 864, so I'm going to put it over here. Okay, so connecting those 2 points gives us our grade B line. And again, those are solid lines because less than or equal to. All right, so we can shade our region now. It's called a feasible region. So it was that we had to have less than, so below the blue line, but then also below the green line. So our feasible region of operation is this line here. Obviously, we can't go into the negative numbers because you can't make negative bags of coffee. So our context tells us that we are above the 2 axes. So this is our feasible region, and what linear programming tells us is that in order to maximize the profit, we want to operate at one of the vertices of this quadrilateral. So, obviously you could make this many bags of each or this many bags of each, but to really maximize it, you want to be on the edge of that shape at a vertex. So we have 4 potential answers or 4 potential places where we might want to operate. Obviously, the origin is not going to be it, because you're not going to get a maximum profit if you make 0 of each. So we really just have 3 points that we need to test. So we're going to test each, wow, good handwriting, vertex. Okay, so, and again, the thing we're trying to maximize is profit. So I'm going to write down each vertex, and I'm going to separate it as E and S. And then the profit is 3E plus 4S. Well, my first vertex, I'm going to mark right here. That's the E value is 176, and the S value is 0. And then I have another vertex right here. That one, the E value is 0, and the S value is 880. Oh, not 880, I'm sorry. I need to look more carefully, sorry. 192. And then the third vertex right here, this is the tricky one. We need to figure out the coordinates of that vertex. I think we can see logically from our graph that it's going to be somewhat less than 176 and somewhat less than 192, but we need to know exactly So we have to solve a system of equations to find that vertex. So our two equations are, and it is right on the edge of the lines, so we have 2e plus 9s equals 1728, and we have 10e plus 2s equals 1760. Again, I use equal here instead of less than because I know that vertex is right on the edge, and that's where it's equal to 1728. So let's see. Let's multiply this equation by -5. And then I'm going to write it beneath so that I can add it together. And the reason I'm doing that is to eliminate the e's. So timesing everything by -5, that gives me -10e. Timesing that top equation, I guess I should say, by -5 gives me -45s. And then 1728 times by -5 gives me -8,640. Okay, so I'm going to add those two equations together. The e's will cancel out. So we have -43s is equal to 1760 minus 8,640 gives me -6880. And then to solve for s, I just need to divide by -43 to get 160. Wow, my best handwriting. There we go. So that was the s coordinate. That's the y coordinate, the second coordinate. We need to figure out the e coordinate there. And we will do that by just going back to one of our other equations. So I'm going to use the equation, the second one, 10e plus 2s equals 1760. Sorry, I think when I'm near the edge of my tablet, the handwriting gets worse. Okay, so if I'm subbing in that 160 right there, I get 10e plus 320 equals 1760. So I can subtract the 320 and then divide by 10. And that gives me that e is equal to 144. Okay, we are so close to being finished. So I have these 3 vertices that we're going to test, and we need to just sub them into our profit function. We're going to sub them in for the E and for the S. So 2 substitutions here. Whoops. So if I do 3 times 176 plus 4 times 0, that gives me 528. If I sub in 0 for E and 192 for S, I get 768. Well, so far that one's better. Oh my goodness. And then finally, I need to sub in 144 for E and 160 for S into, again, I'm subbing them into my profit equation. And that gives me 1,072. So in order to maximize the profits, the maximum profit is 1,072. And to maximize profits, we need to make, we need to make 144 economy bags and 160 Superior Blend bags. Wow, my pen is really winning today. Okay, so that was our first example. So I'm going to break the video up into different examples. So I'm going to end this video here, and but I would really encourage you to watch the other ones as well, especially the mining one that's last, because this is tricky and it is so much involved. So that's the first example. Thanks.